Some nights the sea lights up electric blue as the waves break. It's alive, and the reason it glows is a tiny scream for help. Picture it. You're on a dark beach at night, and every wave that crashes lights up with this eerie electric blue glow. Drag your hand through the water, and it sparkles like you've dipped it in cold neon. It looks completely magical. And the truth behind it is even stranger than magic. Because that light is not coming from the water, it's alive. The glow is made by billions of tiny living things, single-celled plankton called dinoflagellates, each one far too small to see on its own. The most famous is charmingly named Noctiluca scintillans, sea sparkle, a whole galaxy of them, drifting in every breaking wave. And each one is carrying its own tiny chemical lantern. Inside the cell sits a molecule called luciferin. When an enzyme called luciferase grabs hold of it and adds oxygen, the luciferin flares up and then drops back down, throwing off the extra energy as a flash of light. Here's the beautiful part. It's cold light. Almost none of that energy is wasted as heat. Your light bulb should be so lucky. But it only fires when the cell is touched, and the way that happens is astonishing for something with no brain and no nerves. A disturbance, a wave, a paddle, your hand, sends a tiny electrical pulse racing across a membrane inside the cell. A genuine action potential, the same kind of signal your own neurons use. That pulse cracks open a store of protons, the acid floods in, and that sudden drop in pH is the trigger that sets the whole lantern alight. All of that happens inside microscopic packets called scintillans, dotted through the cell like little light bulbs wired to a switch. From the push to the flash takes only a few thousandths of a second, which is why the glow rides the very crest of the breaking wave. Only the cells being jostled right now are firing. The still water beside them stays dark. Now you might be wondering, why blue? Why not green or red? And the answer is lovely. Blue light travels farther through seawater than any other color. Reds and yellows get soaked up within a few meters, but blue slips through. It's the very same reason the ocean itself looks blue. So these creatures evolved to shout in exactly the color the sea carries best. Which leaves the real mystery. Why would a tiny, defenseless speck of plankton want to light itself up like a beacon in the dark? Making light is expensive. Announcing your position to the entire ocean seems like a spectacularly bad survival plan. So for a long time, this was genuinely puzzling, and the answer turns out to be wonderfully devious. It's a burglar alarm. Think about who's trying to eat these plankton. Tiny grazers called copepods, little shrimp-like specks that munch through them in the dark. When a copepod attacks, the plankton flashes, and that flash acts exactly like a shop alarm going off. It doesn't hurt the copepod. It advertises it. It shines a spotlight that draws in the bigger predators, the fish, who happily come and eat the copepod instead. And it genuinely works. In experiments, when the plankton could flash, the copepods grazing on them at night dropped by somewhere between 50 and 80%. The little grazers learn very quickly that biting a glowing cell is a good way to get eaten yourself, so the plankton can't fight back directly. Instead, it turns its own attacker into a snack for something bigger. It weaponizes the food chain. And here's the twist I love most. These cells only glow at night, not because it gets dark, but because they keep their own time. Back in the 1950s, researchers including John Woodland Hastings found that a dinoflagellate kept in constant, unchanging darkness will still brighten and dim on a roughly 24-hour cycle, all by itself, for days. A living clock ticking away inside a single cell that has never read a watch and never seen the sunrise. It just knows. In a few rare places, this reaches a scale that's hard to believe. At Mosquito Bay, on the island of Vieques in Puerto Rico, the water can hold around 700,000 of these organisms in a single gallon. It's the brightest bioluminescent bay on Earth. Every fish that swims through leaves a glowing comet trail, and every raindrop hitting the surface sets off its own little spark. And yet, even now, there's a piece we can't quite explain. We can trace the electrical pulse, the acid, the flash, but that very first step, the exact moment a physical push on the outside of the cell becomes an electrical signal on the inside, is still, in the words of the researchers, an unknown transduction. The trigger works perfectly. We just can't fully say how the cell feels the wave. So the next time you see the sea glowing, remember what you're really looking at. Not magic and not the water. You're watching billions of tiny alarms going off at once. Each flash is a single cell, with a clock and a chemical lantern screaming into the dark, hoping something big enough will come and eat whatever just tried to eat it. The most beautiful thing on the beach is a battlefield. So yes, the glowing sea is alive, and every gorgeous blue spark is somebody having a very bad night. That's one of the ocean's quiet secrets laid bare. There are hundreds more of these little mysteries hiding in the most ordinary corners of the world, and we're working through every single one. Next time, a sound with no obvious source. What makes the sky suddenly boom on a perfectly clear day? Same channel, same little man staring at the sea.